Assalamualaikum warahmatullahi wabarakatuh. This is slide about project sustainable product. We are from group 1. Of content for this slide, first is cover, second is table of content, third is introduction, which is objective, fourth is methodology, which is what the experiment that used in this article, 5 is result or finding, 6 is discussion, 7 is conclusion, and 8 is recommendation. We use 3 articles for this presentation. First is about dolomite sand rock, second is about glass powder, third is about steel powder. First is dolomite sand rock. Dolomite sand rock is one of the materials that can replace conventional sand to various different percentage that form crystalline silica. Objective for this article is to study the use of DRS as a substitute for fine aggregate sand to crushed sand, which is in high demand in the construction industry and considered as environmental issue that happens due to the use of the sand river for the construction. Next is glass powder. Glass powder is the waste glass that should be reused to avoid environmental problems. So the waste glass is collected and crushed and will turn into glass powder and used as replacement as fine aggregate. Objective from this article is to study how much waste glass should be used, identify the suitable waste glass composition used to replace fine aggregate, and also to study the properties of concrete. Last one is steel powder. Using construction demolition waste steel powder because of the high cost in natural sand that is used as fine aggregate. Steel powder is already used in asphalt paving as aggregate. Objective from this article is to study the effect of the use of steel powder as a substitute for fine aggregate on various strengths and durability properties by using graded of M20 of mixed design.
Okay, for methodology, for dolomite rock, steel powder, and glass powder, all of them use the same method, and the method are slump test, compressive strength test, split tensile test, and flexural strength test.
For construction demolition waste, these are the findings of concrete that contain 0%, 30%, and 40% of construction demolition waste. And these are the findings for dolomite rock sand and glass powder. For dolomite rock sand, the percentage of dolomite rock sand in concrete that being used are 20%, 25%, and 30%. And for glass powder, 10%, 20%, and 30%. Discussion. For construction demolition waste, from the findings of the test, replacing 30% of the fine aggregate with steel powder increased the compressive strength of concrete by 4.6%. Replacement of 40% steel powder, the concrete strength is increased by 27.04% and shows it has the highest compressive strength value. For dolomite rock sand, the data produced showed that the compressive strength increased but decreased again when at the point containing 40% dolomite rock sand, and the highest compressive strength was at the point where 20% of this material was contained. For glass powder, when the amount of glass with powder as fine aggregate replacement was increased, the compressive strength values were approximately increased as well. The highest compressive strength were with glass with powder replacing 20% of the concrete. These are the findings of construction demolition waste or tensile string. And also this is for dolomite rock sand and glass powder. This is our discussion based on tensile string data. Construction demolition waste, the tensile string result for this material increased a bit. From the 28 days data, we can see the tensile string for 40% replacing is the highest, while the others are just the same. Dolomite rock sand, the tensile strain increased but decreased again when at the point containing 40% dolomite rock sand as fine aggregate, and the highest tensile strain was at the point where 20% of this material was contained. For glass powder, we discovered from this article that after replacing glass with powder by more than 20%, the strain was lowered. With increasing percentage of with powder substitution, split tensile strain decreases, and the highest strain is at 20% replacement. These are the data of flexure strain of construction demolition waste, and this is for dolomite rock sand and glass powder. And this is a discussion based on flexure strain for construction demolition waste. When 40% fine aggregate replacement was used instead of 0%, the flexural strain of the concrete increased by 40% and shown that it has the highest flexure strain. For dolomite rock sand, the flexure strain increased but decreased again when at point containing 30% dolomite rock sand as fine aggregate, and the highest flexure was at the point where 20% of this material was contained. Glass powder increase in the percentage of glass with powder as fine aggregate increases the flexure strain of concrete by up to 20%. The maximum flexure strain was found with a 20% substitution of glass with powder.
For the conclusion, from the discussion, we can conclude that result for the slump test compressive, tensile and flexural strength for these three materials do not have much difference. So, I recommend using these three materials to use as a replacement for fine aggregate because it can reduce environmental issue. But for use in Malaysia, I recommend using glass powder and steel powder because this waste material is easy to find and low cost, while dolomite rock sand is usually found in Manila. Recommendation that can recommend from this article is first for dolomite rock sand is suitable fine aggregate when mixed with crushed sand in optimum proportions. It also shows better performance than conventional concrete in terms of both strength and durability. Next is a recommendation for glass powder. To achieve a better result, glass with powder replace with fine aggregate by 20%. Up to 20% of natural fine aggregate saved from this replacement of glass with powder as fine aggregate. Last is steel powder. Partial replacement of fine aggregate by steel powder improve the compressive, tensile and flexural strength of concrete.
Okay, for recommendation, I recommend to do one more test of using these three materials as sand replacement, which is water permeability test. The water permeability test is one of the tests to determine the durability of concrete. Okay, I recommend this water permeability test because in those articles the author didn't mention it.
This is the reference that we use for this slide. That's all from us. Thank you.